All right. Good day once again, and welcome to another JAMB class on chemistry. Today, we are going to be considering the topic water. The topic water, that is what we are going to be considering. And for the benefit of those that may be joining in for the first time, I would like to introduce myself. My name is Anjori Oluwafemi Excel. I hold a BSc in chemistry from the Premier University, University of Ibadan. I also hold a postgraduate diploma in education. I majored in science education, chemistry to be precise, and from the Federal College of Education, Technical Akoka. I also hold a degree, a master's degree in environmental and analytical chemistry from the Redeemers University, Ede, Ocean State. And I'm going to be your teacher for this particular topic, and the title is Water. Now, let's look at our learning objective as we proceed with this class. So, it is expected that by the end of this class that you are able to identify various uses of water. It is also expected that you should be able to identify the effect of dissolved environment. Sorry, please. Let me take that again. It's also expected that you identify the effect of dissolved atmospheric gases in water and to distinguish between the properties of hard and soft water and to determine the causes of hardness and also state methods of removal of hardness in water and describe the process involved in the treatment of water for the town supply and distinguish between water crystallization, efflorescence, the liquescence, and hygroscopy. And finally, to be able to state the various compounds that exhibit these phenomena. So these are our learning objective for this topic, and we'll jump right into the class now. Water. Water is something that we have all heard of. We make use of water on a daily basis. And if you remember, for those that are Nigerians among us, you discover that a popular musician sang a song. He said, "Water, a no get enemy." What does that mean? It means that everybody is mandated to be a friend of water or with water. Whether you like it or not, you have to use water. And that is why I said, "Water, a no get enemy," so to speak. Well, that's on a lighter note. And then we're jumping into the class now. Water is basically one of the most essential substances on earth, and it covers about 71% of the planet's surface. That is quite massive, don't you think? Yeah, it is quite massive. Water covers a large chunk of the planet. That means that what you have as solid land or solid ground, so to speak, is so minute compared to the portion occupied by water. Now, water exists in different states. It exists as a solid. It exists in a solid state, which we call ice. It exists in a liquid state, which we call water, and then it exists in a gas state, which we call steam or water vapor. Now, the chemical formula for water, like we know, is H2O, and it represents two hydrogen atoms covalently bonded to one oxygen atom. And you can actually see the diagrammatic display of the bonding there. You have two hydrogen atom, and then it is bonding together with one oxygen atom. And that gives us, that arrangement, and that is the chemical formula for water. All right. Okay, let's move along now and talk about the physical properties of water. So, what are the physical properties of water? One, water is colorless and tasteless. Any water that you see that is okay is oftentimes colorless and it is also tasteless. Hydrogen bonding is a physical property. Extensive hydrogen bonding between water molecules contributes to its unique properties. Then water has what we call high melting and boiling points. The boiling point of water is so high that before water will boil, it will get to 100 degrees centigrade. So it is quite high. So due to strong hydrogen bond and water has unusually high melting and boiling points compared to similar molecules. Another thing again that we need to consider is the high specific heat capacity of water. Water can absorb and retain heat efficiently, making it essential for temperature regulation in the environment and living organisms. And that is why water is very, very important. It's extremely important, to living organism. It helps in, retaining or regulating temperature, as the case may be. Now, high thermal conductivity is another physical property of water. It facilitates efficient heat transfer, aiding in biological and environmental temperature regulation. Water also has what we call high surface tension. So the water molecules exhibit strong cohesive forces, allowing water to form droplets and support small objects. Excellent solvent, and that's a very unique quality or property of water, capable of dissolving a wide range of ionic and polar compounds essential for transporting nutrients and waste and biological system. So high dipole moment is another physical property of water. And water's polar nature contributes to its ability to dissolve many substances, making it what we call a universal solvent. So water is a universal solvent because it has high dipole moment. All right, now let's move along and look at the next one. That's the chemical properties of water. Having considered the physical properties, it's important that we look at the chemical properties of water also. And what are the chemical properties of water? Sorry, I think I moved the slide. Okay, so water reacts with a lot of substance to form different compounds. Some significant reaction as follow. One, water, one of the chemical properties that it is amphoteric in nature. It can act as an acid. It can also act as a base. That's the meaning. Redox reaction. Water can participate in oxidation reduction reaction. So electropositive element can reduce it to produce hydrogen gas and then oxidize it to form oxygen. Another chemical property of water is hydrolysis. Water has a strong hydrating tendency due to its high dielectric constant, allowing it to dissolve many ionic compounds. It also facilitates the hydrolysis of ionic and covalent compounds, breaking them down into simpler substances. So these are some of the chemical properties of water that are unique, to water, so to speak. Now, why do we look at water as a solvent? Why do we consider water to as a solvent, so to speak? Water as a solvent. In looking at water as a solvent, just hold on. Let me hide these components so that it does not just keep distracting me, so to speak. Just hold on, please. Hmm. Hmm. Okay. Okay. So yes, thank you. So I want to look at water as a solvent now. Looking at water as a solvent. Water is called um, water is called a universal solvent because it dissolves many substances. Now, the polar nature of water allows it to dissolve ionic and polar covalent compound. Water naturally dissolves gases from the atmosphere, which affect its chemical properties. Now, let's look at a particular gas called oxygen. Oxygen is essential for aquatic life, as fish and other organisms use dissolved oxygen for respiration. Another gas is carbon dioxide, CO2. It reacts with water to form carbonic acid, H2CO3, which contributes to ocean acidification and affects aquatic ecosystem. Also, another gas like nitrogen, generally inert but may contribute to eutrophication when combined with other nitrogenous compounds. And in case the word eutrophication is a bit new to you, what it simply means is the excessive enrichment of water body with nutrients, causing rapid growth of algae and plankton. This leads to algal blooms, which can disrupt aquatic ecosystem. Sulfur dioxide, which is SO2, and nitrogen oxide dissolves in water to form acid rain, which leads to environmental degradation. It leads to environmental degradation. Okay. Another thing that is important for us to look at is the uses of water. Yes, the uses of water. Like I was saying earlier, that virtually all of us use water for one reason or the other, and we can't do without using water. Water is essential for life. Water is used in so many things, and some of the things that we use them for: one, domestic use. We drink water, we cook with water, we clean with water, we bathe with water, we do our laundry with water. In the world of agriculture, water is also used for irrigation, livestock hydration. You know, the cows have been roaming about, they need to be hydrated. You give them water. And for aquaculture, you know, these are areas in agriculture that we make use of water. Industrially, water is used as a solvent in chemical reaction. It is used as cooling agent in factories and power generation in hydroelectric plants and production of beverages. So industrially, we can use water for those things I've stated. And in transportation, water can be used as a source for navigation. So for rivers, for lakes, for seas, and so on and so forth, as well as in ship and submarine. So we can move goods from one point to the other using water. You know, we can use the lake, we can use the sea, you know, or the rivers, as the case may be. You know, water can also be used in as a recreational tool. And in this regard, it is used for in swimming, you know, fishing and water sports like water polo and kayaking and so on and so forth like that. Biological function. Water is very, very important for digestion, extremely important for digestion. Also for excretion, circulation, and photosynthesis in plants, we need water and we make use of water. All right. Now, hard and soft water. What makes a water hard? What makes a water soft? Now, hard water contains the salts of calcium and magnesium, making it difficult for soap to form lather. Hardness of water can be classified into two. Please don't forget, the reason why water is said to be hard is because it has dissolved salt of calcium or magnesium in it, and it does not allow it to be able to form lather with soap, so to speak, or for soap to form lather properly. And hardness can be classified into two. We have temporary hardness and then permanent hardness. Temporary hardness is caused by dissolved bicarbonate, that is calcium hydrogen carbonate and magnesium hydrogen carbonate rather, and it can be removed by boiling. So temporary hardness of water is easy to remove. It can be removed, you know, by using boiling. Pardon me, please. So we can use boiling to remove temporary hardness. The second type of water hardness is called permanent hardness. Now, permanent hardness is caused by sulfates, that is sulfate of calcium, that is calcium sulfate and magnesium sulfate. It is also caused by chlorides of calcium and chlorides of magnesium, calcium chloride, magnesium chloride. It requires chemical treatment for its removal. So please let us quickly establish this, that for temporary hardness, it can be removed by boiling, while permanent hardness can only be removed by chemical treatment. Now, these salts, that is, the salt of calcium and magnesium, originate from geological formations such as limestone, chalk, and gypsum, which dissolve into water sources. Okay, I will talk about hard water now. Let's take a look at soft water. Now, salt water lacks significant concentration of calcium and magnesium salts, allowing soap to lather easily. Rainwater and distilled water are examples of salt water. In the comment section, I want you to put in for me the examples of hard water that you know. I've given an example of salt water to be rainwater and distilled water that we use in the laboratory. So in the comment section, tell me examples of hard water that you are conversant with. All right, thank you. Now, moving along now, we look at the effect of hard water. What are the effects of hard water? Number one, it reduces soap efficiency. Hard water react with soap to form what we call scum, that whitish thing that you see, it forms scum, preventing lather formation. That's one of the disadvantage, or sorry, not disadvantage now, the effect of hard water. It forms scums, and synthetic detergent do not form such scums anyway. But when we have some bar soap and some other soap, it may. And the reason why synthetic detergent do not form scum is because it has been designed in such a way that it has what we call a hydrophilic and hydrophobic component that enables it to be able to overcome scum, in the sense that overcome the calcium or the magnesium salt that is in hard water, so it can lather with hard water, so to speak. But other types of soap, most of the time, will form scum and they will not lather. No lather will be formed when they are used. Second effect of hard water is causes scale formation. Now, deposits of calcium carbonate and magnesium hydroxide and calcium sulfate clog pipes and appliances, and scale build up reduces water flow and heating efficiency. For some of us that have used hard water before and you have tried over time, you saw that something will just keep forming either on your boiling ring or in your kettle or in your pipes, and it keeps on building up. When it builds up, it can even affect the water flow. It can even affect the eating efficiency of that material that you're using to eat such hard water, and so on and so on. So it can cause scale formation, just boiling ring or in the kettle that you use in boiling. Another effect of hard water is damages boilers and heating system. When the scale build up, the scale will impair heat transfer. So heat will not be able to transfer appropriately through the boiler and the heating system, and it leads to overheating and potential boiler failure. Another effect of hard water is it leads to galvanic erosion. Galvanic erosion. Hard water can accelerate metal corrosion when different metal come into contact in plumbing system. So when this metal comes together like that, it results in what we call galvanic erosion, whereby the ions of the metals will keep on depositing, and then they will corrode the whole system and will make your ability to use that particular system for boiling of whatsoever to be next to impossible, so to speak. Another effect of hard water is that it causes cloudy pool water. If you have hard water in a pool, hard water reacts with carbon dioxide, forming insoluble carbonates, leading to turbidity in swimming pools. So when you go to a swimming pool and you discover that the swimming pool is cloudy, the reason is because the water in it is hard. It's hard. And one of the ways we can manage this is by adjusting the pH with hydrochloric acid, and that will solve that problem. Okay, having talked about the effect of hard water, we can move further by looking at the removal of hardness in water. How do we remove hardness in water? Now, for temporary hardness of water, like I said earlier, it can easily be removed by boiling. Now, when you boil, you convert the bicarbonate into insoluble carbonates, e.g., calcium carbonate, that can be filtered off. So we can remove temporary hardness by boiling, and we can also remove it through what we call the Clark's method. The Clark's method simply involves, it's all about addition of slake lime to precipitate calcium carbonate or bicarbonate rather. So when you add slake lime to the hard water that is temporarily hard anyway, and it will precipitate calcium bicarbonate, and by so doing, you are able to remove what the hardness in water. For permanent hardness of water, you need to go a notch further. You need to do something more than just boiling or Clark's method. And one of the ways we remove permanent hardness of water is the addition of washing soda. Washing soda is simply Na2CO3, sodium triacylcarbonate 4. So when sodium triacylcarbonate 4 reacts with calcium and magnesium ions, it forms insoluble carbonates. By so doing, it removes the permanent hardness. We can also do what we call an ion exchange method, in which we use a resin to replace calcium and magnesium with either sodium or hydrogen ion, as the case may be. We can also use the zeolite process, in which we employ natural or synthetic zeolite, to exchange sodium for calcium and magnesium. By so doing, you render, that water free of those ions that are causing hardness, permanent hardness to be precise. We can also remove permanent hardness through the process called distillation. It converts water into steam, condenses it to remove dissolved salts completely. So when we distillate, we can actually remove permanent hardness in water. All right. Now, I would say that let's look at the different types of water and what are the advantages and the disadvantages of this water. We've talked about the two major different types of water. And the two major types of water that we discussed are hard water and soft water. Now, what are the advantages of hard water and what are the disadvantages? Number one advantage of hard water is that it contains essential minerals like calcium and magnesium that can be beneficial for health, calcium for bones and so on and so forth like that. So that's one advantage. Another advantage is that it has a better taste due to the presence of mineral. Wow. So who say that when you take hard water, it has a better taste because it has dissolved minerals in it, another advantage of hard water is that it strengthens the bone and teeth due to calcium content. Okay, so it strengthens the bone and the teeth due to calcium content. Another advantage of hard water is that it may help reduce the risk of cardiovascular diseases. So because of the content of all these ions, magnesium and calcium in it, it can help in reducing cardiovascular diseases because it can replace sodium, so to speak, that can spike up blood pressure or cardiovascular diseases. So by so doing, it reduces the risk of cardiovascular diseases. Another disadvantage of this, like we said earlier, reducing the effectiveness of soap and detergents. Number two is that it causes scaling in pipes, boiler, and appliances, leading to blockage and inefficiency. And then hard water leads to higher energy costs due to reduced heating efficiency. It is unable to transfer the way it's supposed to. So you will discover that you use more energy to boil just the quantity of water that you shouldn't use as much energy as you are using due to the formation of scales and all in the boiler or in the ketchup, as the case may be. Also, hard water disadvantage, it can cause rough, dry skin, and dull hair. So these are some of the disadvantages of hard water. Now let's move on to soft water and look at the advantages. Number one, it lather easily with soap, reducing soap usage. So when we use soft water, the quantity of soap that we make use of will be reduced drastically. Number two, it prevents scale buildup in pipes, boiler, and appliances, prolonging their lifespan unlike hard water. Another advantage of salt water is that it enhances the effectiveness of detergents, leading to cleaner clothes and dishes. The fourth advantages of or advantage of soft water is it prevents soap scum formation, making cleaning easier. So you don't need to apply so much soap or start to scrub before you remove any dirty things. It makes cleaning easier. It prevents soap scum formation. So what are the disadvantages of soft water? Number one, it lacks essential minerals, which may not be beneficial for health. Number two, it can have a slightly salty taste if softened with sodium-based ion exchanger. That's a disadvantage. Number three is that it can leach metals into pipes, potentially leading to contamination. So it's the metals that you use for softening can actually be leached into the pipes and then can result in contamination. The next disadvantage is that it may not be ideal for drinking in the long term due to the absence of beneficial minerals. So we have seen the advantages and the disadvantages of the different types of water. So please take note of that because the evaluation will also cover um, these differences that or advantages and disadvantages that we've been able to state out. All right, how do we treat water for town supply? For us to be able to treat water for town supply, to ensure that we drink safe water, a series of purification steps have followed. Number one is screening. And what do we do with screening? Large debris like leaves and plastics are removed using a metal grid. That's the first thing that is done. The second thing that is done before a water can be, supplied to towns and cities and all that is what we call coagulation and flocculation. Chemicals like halon, are added to trap dead particles. Some of us have used this before in our homes. Whenever we go to either fetch water from the well or we have rainwater that's a bit dirty, sometimes we just put the halon inside. So what we do is just like to coagulate, to pick up the dead together, to gather them together, and then you see them being deposited at the bottom of your container as you go on. So the next step in purification of water or for treatment of water is sedimentation. Sedimentation has to do with suspended solid settling at the bottom of large tanks. So after they have been coagulated and flocculated, what happens is that it will now settle at the bottom of the tanks. Then thereafter, filtration process comes in. The water passes through sand and gravel filters to remove fine particles from them. Then after that, the next step is chlorination. Chlorination is basically the addition of chlorine gas to water in a quantity that is permissible anyway, in order to kill harmful microorganisms. That's chlorination. Another step or another process that water goes through before it is purified, is called fluoridation. For fluoridation, what we are doing is that fluoride compound will be added to prevent tooth decay. Fluorine is very good for the teeth, so to speak. So, and then after that, you now do a storage and distribution. The treated water is stored in reservoirs and delivered to homes through pipes. Now, this is a little schematic of what happens in water treatment. All the steps I've made mention of, you can see them outlined in this diagram. And that is how water goes through treatment before it is supplied to our homes or supplies to cities and towns and communities around us. Okay, having said that, we need to look at some phenomena like water crystallization, efflorescence, the liquescence, and hygroscopy. Now, when we talk about water crystallization, what is the definition? It is simply the fixed amount of water molecule chemically bond within the crystal structure of a compound. These water molecules are essential for maintaining the crystal shape and properties. An example of water crystallization is what you see in copper 2 sulfate pentahydrate. That's CuSO4 dot 5H2O. It has water crystallization. Five molecules of water is attached to that to copper sulfate. And then you can have that also with iron 2 sulfate heptahydrate. Then efflorescence is another phenomenon that we should look at, and it is basically the spontaneous loss of water or crystallization when exposed to air. So you have some substances that when they're exposed to air, they will lose their water of crystallization, and it will cause the substance to become powdery. They lose their water of crystallization, and then the substance becomes powdery. Now, this happens when the vapor pressure of the hydrated compound is higher than that of the surrounding air. That is what results in efflorescence. Examples of substances that can go through efflorescence are sodium carbonate decahydrate, magnesium tetraoxosulfate, magnesium tetraoxosulfate, 6 heptahydrate, and then we have the liquescence as another phenomenon that we must also be conversant with. And we said is the process in which a substance absorbs moisture from the air until it dissolves into a liquid solution. This occurs when the substance affinity for water is strong enough to attract and retain water molecules from humid air. So when you have a process whereby a substance will absorb moisture from the air until it dissolves into a liquid solution, this is called the liquescence, or that phenomenon is called the liquescence. And we said it occurs when the substance affinity for water is strong enough to attract and retain water molecule from humid air. Example of substances that undergoes the liquescence are sodium hydroxide. For some of us that have seen this before, sodium hydroxide exists like as a pellet, a white pellet. So when you put it in a maybe in a crucible or something, just leave it there. After a while, when you come back, you discover that it has turned into water completely, and that is because it is the liquescence in nature. Calcium chloride is another one. So for substances like this, we keep them in what? In containers that will not expose them to air. Now, hygroscopy is another phenomenon that we should be conversant with, and it is the ability of a substance to absorb moisture from the air. Now, take note of this without dissolving into a liquid. So, for the liquescence, it will absorb moisture from the air, it will dissolve into a solution. For hygroscopy, on the other hand, it will absorb moisture from the air without dissolving into a liquid. Such substance remains solid but may become damp or sticky. And that's the difference. Example of hygroscopy is silica gel. Concentrated sulfuric acid is another example, and then glycerol is another example of a substance that is hygroscopic in nature. All right, having said that, let us summarize this lesson. We have talked about water, we have defined water, we have talked about the physical properties of water, we have talked about the chemical properties of water. We have also made mention of the different uses of water, domestic, industrial, agricultural, and so on and so forth. We've touched on water types or classification of water, in which we can classify it to be either hard water or soft water. We talked about the types of hardness in water. So there's temporary hardness, there's permanent hardness, and the reason why water is hard is also stated that in the course of this lesson. We've also mentioned or touched on water purification for town supply and the various steps that we use for water to be purified or to be deemed or certified consumable for humans, as the case may be. So we made mention of those steps from screening them to coagulation to flocculation to sedimentation to chlorination to fluoridation and then to getting them into filtration and then getting them into what's it called? Storage tanks and then transferring them through water pipes to our homes. So we talked about this and we need to evaluate our lesson now. But before I start with my own evaluation that I've drawn out, I would like you to please, if you have any question based on this topic, drop your questions in the comment section and I will react accordingly to them. Just drop them in the comment section and then I will react and take them on from there. So the first evaluation or the first question that I'm going to be using to evaluate our class is that what is the molecular formula of water? If you know the answer, please put it in the comment section. Which of the following is not a property of water? And look at all the properties listed. Which one do you think is not a property of water based on what you have discussed? So drop your answer also in the comment section and say the ability of water to dissolve many substances due to its, and we touched on this, is it because of the non-polar nature? Is it because of its amphoteric nature? Is it because of its high dipole moment or high thermal conductivity? If you know the answer, put them in the comment section, please. And we talked about the high boiling point of water compared to similar molecule is due to what? Why do water? I talked about the fact that water has a boiling point of 100 degrees Celsius. It will take a whooping 100 degrees Celsius for water to start boiling. Why is that? What is responsible for it? Part of what I taught in the course of the lesson. So please put your answer in the comment section. Water is described as an amphoteric substance because why? Why do we describe it as a amphoteric substance? Amphoteric in nature, it has a dual nature. It can do something, it can act as this, it can act as that. Two things at the same time. Tell me what or why do we describe water as an amphoteric substance? So put the answer in the comment section for me and I'll pick it up and respond appropriately. Now, which gas in water is essential for aquatic life? Yeah, so which gas did we touch on that is essential for aquatic life? Well, you put your question, your response also in the comment section and I'll pick it up. So acid rain is mainly caused by which gas? We talked about this earlier, and that acid gas is caused by when a particular gas dissolves in water. Is it oxygen and nitrogen? Is it carbon dioxide and oxygen? Is it sulfur dioxide and nitrogen oxide or hydrogen and methane? Your response in the comment section. And also talk about eutrophication in water bodies. We said it is caused by excessive what? Is it nitrogen compound, sulfur compound, oxygen, or carbon dioxide? your response, please. Let it go into the comment section and I'll pick it up appropriately. We also touched on hard water, and we said hard water is characterized by the presence of two major ions. Please, if you know the answer from the options listed there, please put them in the comment section. I will react to it appropriately. And we said the type of hardness removed by boiling is, who can tell me that? Okay. So please put your response in the comment section so that I'll be sure that you actually got all that I've taught this today. Okay. So these are other evaluation based on water crystallization. So please go through them one after the other and put your answer in the comment section the of the of this video. Thank you so very much for watching this video, and I hope this will greatly help you in your JAMB class. I wish you all the best. I'll see you in the next video. Thank you for now and take care. Bye bye.